Hi friends, myself Anshu Srivastav. Welcome to Never Stop Learning platform. I hope all of you are okay and enjoy your weekend. Friends, today we are going to start one interesting topic and its name is electronic capacitor. I hope you are already familiar with the capacitor, their functions and the applications in the real life. So let's have a look. A capacitor is a passive electronic components that store electrical energy in an electrical field. It is essentially a storage tank for electricity capable of releasing energy much faster than a battery. If you see this image, right hand side image, there are multiple capacitors with different types. This ability is quickly store and discharge energy makes Capster vital in various applications from filtering noise in the audio system to stabilize voltage in power supplies. Just see the symbol in the second diagrams. Fixed capster, it has to be shown like this, and polarized capster, see the curve, and a variable capsters, just make one arrow, okay, on that capster by which you can vary the capster value. So just come to another slide. The core functions capster. When we talk about a capster, so a real picture, it has to become in our mind, and after that, if you see the first image, there are two metal plates. One is your anode, other is your cathode, and there is a separator between two metal plates, and that separator we call as dielectric. It may be ceramic, plastic, films, or air. The terminals of this capacitor, one is your anode and other is your cathode. Anode is always positive polarity, cathode is your negative polarity. Now we discuss about the second point, charging. If you see, when a voltage is applied, the positive energy accumulates on the one plate and negative charge on the other plate of an electric field across the dielectric. So it is very clearly that whenever you connect a battery and the battery polarity, positive polarity is connected with anode and negative polarity of the battery is connected to cathode. So the current always flows from positive to negative directions. So the positive charges accumulates on anode plates and the negative charges accumulates on cathode plates. And then the dielectrics, the electric field is generated across the dielectric. And the third image is your energy storage. When your capacitor is fully charged, no current pass through the dielectric. Instead, the energy is stored in the static electric field until the capacitor is discharged. Now, the another topic is types of capacitor. See, there are various types of capacitors, and all of them are specific in their applications. One is your super capacitor, tantalum capacitor, ceramic capacitor, silver mica capacitor, variable capacitor, film capacitor, polyester capacitor, and for polypropylene capacitor. So let's discuss about the parallel plates capacitor. Now, both the plates, anode and cathodes, they are parallel, having a distance d, and each parallel plates, the area of that parallel plate is your A, that is called area of cross section. So here the two main things you have to remember: how to get the value of capacitor, that is, the formula is mentioned here. Its permittivity A upon D, and if you want to calculate the energy storage in a capacitor, E is equals to half CV square, and its unit is in joules. Now the concept of charging and discharging capacitor. When connected to a direct current voltage source, the capacitor discharge the capacitor charge almost instantaneously, but they can discharge just as fast if shorted. However, with some resistance in place, the rate of charge and discharge is exponential rather than direct. So if you see the circuit, the resistance is connected in series with the capacitor in both the charging as well as discharging concepts. And in first image, we have to give a source to the capacitor. So the charging of the capacitors charge in a exponential way, whereas the discharging of the capacitors charge in the reverse way. And they are the charging formulas. We can collect the voltage of the charging formula as well as the discharging formula. And oscillator waveforms, shapers, and the low discharge power backup circuits are the examples of electronics that leverage controlled charge and discharge rates. Now, the applications of capacitors in the real life: the energy storage in electronic device, DC power supply filtering in electrical system, coupling and decoupling signals, high pass and low pass filters, the power factor corrections, the signal processing in communications systems, touchscreen technology, medical image and diagnosis, motor starts and run capacitor, and turning radio frequency by gang condensers. So I hope guys you enjoyed this video, and thank you very much watching my channel, and please subscribe my channels. Thank you so much. Have a nice day.